A darkness without edges drifts at the fringe of the sun's dominion, gliding through space, with the poise of something that has travelled far longer than humanity has existed. It carries no message, no roar of engines, no signature of heat or collision. It enters silently like a misplaced thought in the mind of the cosmos. Astronomers will later designate it 3I Atlas, the third confirmed interstellar object ever detected. Yet long before a name is attached to it, before its path is plotted or its properties debated, its presence alone unsettles the quiet architecture of the solar system. It is not merely passing through. Something in its movement, in its surrender to the sun's growing pull, hints at intention. As if the object has known this star before and has returned, for reasons older than the planets circling it. At first detection it appears unremarkable, another wandering ice fragment from the deep galactic night. But its origin is older than comets, its speed greater than any long-period traveller tied to our star. It races inward at more than 124,000 miles per hour, cutting through the scattered dust and minor bodies, like a blade through darkened water. Its surface glints with a muted hue, light sliding across it, as though touching a structure not fully familiar to nature. In observatories across Earth, the first data points land gently, almost innocently, onto screens. A few astronomers blink. A few graphs seem off by a fraction. Nothing dramatic. Nothing yet. But anomalies have a way of gathering mass like a snowflake rolling into an avalanche. Within hours, orbital models begin to behave oddly, as if the object is slipping through the calculations rather than being bound by them. Its approach angle is unlike the chaotic trajectories of the previous interstellar visitors. Instead, it follows a path almost eerily aligned with the ecliptic plane, the narrow, fragile disk, where every major planet forms its quiet clockwork around the sun. This is not where interstellar debris tends to fall. It is the solar system's thin, improbable highway, and the newcomer glides along it with the precision of a traveller who studied the map before arriving. Yet even this is only the first whisper of strangeness. As weeks pass, the object's projected course tightens. Instead of swinging around the sun in a wide ballistic arc and escaping into the stars as nearly all natural interstellar bodies, its trajectory begins to dip as though preparing to descend deeper into the sun's gravity well. Models refine, predictions sharpen. By the time global agencies compare notes, the same frightening possibility appears in every independent simulation. 3I Atlas may not be leaving. If it continues on this course, if it threads the needle behind the sun with unparalleled precision, it could experience a maneuver known in astronautics, but essentially non-existent in nature. Using the star's gravity as an amplifier, the object could reduce its outbound velocity enough to fall into a stable solar orbit, becoming a long-term resident rather than a visitor. Natural bodies cannot do this. Not without outgassing jets, violent fragmentation, or some asymmetry that violently alters their momentum. But 3I Atlas shows none of these signs. It is cold, steady, unflinching. And the closer it draws, the more unsettling its silence becomes. In mission control rooms, engineers and physicists lean closer to screens. They examine brightness curves for clues of venting gases. They search for rotation signatures that might hint at instability or tumbling. Instead, the data returns a portrait of improbable stillness. No jets burst from its surface. No coma forms. No tail emerges. And as it passes through regions where sunlight should peel particles from its exterior, nothing happens. Like a stone polished beyond erosion, it remains unchanged. Its size becomes a point of contention. Based on reflectivity, the object should be a mountain of ice and dust, yet its gravitational influence on nearby spacecraft is almost non-existent. If it is large, it's impossibly light. Hollow, perhaps, thin-shelled, crafted rather than carved. But such conclusions are not spoken aloud in the early days. Even the most daring astronomers swallow their instincts, holding back the words that might echo for centuries. Because there is a psychological threshold in science, one that trembles when the unknown begins to resemble design. As Atlas moves inward, its elegance begins to feel accusatory, as if exposing our ignorance of the galaxy's deeper currents. The solar system reacts to its arrival not with dramatic disturbances, but with a strange quiet rearrangement of certainty. Telescopes track it relentlessly. The sunlight around it brightens. Temperature models strain to explain its unreactive shell. And as it glides closer to the sun's furnace, the object shows no fear of annihilation. No shedding, no fracture. It treats the oncoming blaze not as threat but as opportunity. The deeper the object falls into the sun's gravity well, the more profoundly it challenges the human desire to categorize. Scientists begin to whisper privately about motive forces about orbital precision, far too exact for randomness. If it were a simple interstellar shard, it would behave like one chaotic tumbling shedding mass. But this object is poised, aligned, and obedient to a kind of trajectory management unknown to natural bodies. Most comets announce themselves with drama. This one carries the quiet of purpose. And then the final detail as it descends its calculated point of closest approach lies precisely behind the Sun from Earth's perspective. The one region where no telescope, no sensor, no array can maintain visual contact. For several days the object will vanish entirely. A comet might do this by accident. A visitor with intent might choose it deliberately. In the hours before it disappears into the glare, observatories send out final frantic bursts of data collection. Space agencies synchronize clocks. Solar probes brace for intense radiation to catch any anomaly during the hidden passage. Yet even as instrumentation is primed, a question settles heavily across the global scientific community. A question spoken quietly, almost fearfully. What if this is not a coincidence? The stopwatch of the cosmos begins counting down to a moment shrouded in plasma, and fire, a moment that could illuminate the nature of the object, or bury it forever in silence. Three-Eye Atlas slips behind the sun like a secret being folded into the heart of a star, and humanity waits suspended between dread and wonder for whatever will emerge. When the first alert came through the automated survey networks, it did not carry the weight of revelation. It was merely a faint point of motion against the tapestry of background stars flagged by the Atlas survey on Mauna Loa as another cold object wandering through the dark. Yet within minutes of its identification, additional observatories began tugging at the early data, each running quick orbital estimates, each returning results that hinted at something quietly astonishing. The coordinates did not match any known long-period comet, nor any dormant rock drifting near the Kuiper belt. Instead, the numbers whispered a truth still too early to speak. This object came from beyond the Sun's family entirely. Interstellar objects had already begun reshaping modern astronomy. The first Oumuamua arrived like an unexpected punctuation mark, a thin sliver moving with the indifference of a visitor simply passing through. The second comet, Borisov, behaved more like a traditional ice body, though its chemistry spoke of distant stellar nurseries. But this third one, designated 3I for its place in the sequence, carried a strange gravity of narrative, even before its physical gravity was understood. It moved with a steadiness that made the data analysts pause between keystrokes as if the object were following a choreography, written far from the solar system's turbulent birth. Its path was aligned in a way that felt unnatural for something born in the violent expanse between stars. Nearly every interstellar traveller approaches from directions unbound by the flat geometry of local planets. But 3 Atlas entered the solar system not from above or below the ecliptic, but along it, threading itself into the same shared plane as Earth, Mars, Jupiter, and the rest of the planetary procession. The initial angle of entry was so precise that several researchers assumed a computational error. It took repeated independent confirmations from surveys in Chile, Hawaii, and the Canary Islands before skepticism softened into a contemplative unease. As the detections accumulated, observatories began to pull from their archives, searching for earlier glimpses of the object when it was still faint and distant. A few small exposures appeared dusty and faint but consistent. Even months earlier, when it was barely more than a whisper against the noise, its trajectory aligned with a path that a random interstellar object would almost never take. The odds were microscopic. Even then, patterns were forming patterns that suggested a kind of gentleness to its steering, as though the object approached the Sun with a familiarity that no natural wanderer possessed. The team at the Atlas survey, used to cataloguing thousands of mundane fragments every year, was among the first to sense the threshold they had crossed. They watched as orbital calculations updated in real time each revision, placing the inbound trajectory closer to the plane of Earth's path. Yet the lack of cometary features puzzled them. A typical comet warms as it approaches the Sun, shedding gas, forming a coma, producing the luminous tail that announces its presence across the heavens. But 3 Atlas remained bare. Light bounced from its surface sharply as though from something far more reflective than ice, while its structure deduced from brightness. Fluctuations implied slow rotation without the stuttering tumbles that irregular bodies exhibit. Still, the discovery phase remains governed by restraint. No agency, no laboratory, no astronomer leaps to conclusions at the outset. Professional caution acts as a buffer against imagination. So the initial papers described only what could be proven: an interstellar trajectory, an unusual alignment, an anomalously smooth light curve. The raw data hinted at more, but across the globe researchers tightened their focus on what could be measured: reflectivity, periodicity, rate of approach. They dissected each fragment of information without yet acknowledging the shape of the whole. But the deeper the object fell into the inner solar system, the more tightly its story wove itself around the human observers tracking it. Small details became points of fixation. One especially telling moment came from the Pan-STARRS Observatory in Hawaii, when an early photometric sequence revealed almost no variation in brightness. Over a span of hours, an oddity suggesting a remarkably symmetrical object. Natural bodies rarely display such symmetry. They spin unevenly, their surfaces jagged and chaotic from eons of collisions. This one glimmered like a stone carved deliberately polished by hands unknown. Then came the confirmation that shifted the tone from curiosity to alarm. Teams in Europe and Japan independently computed the object's inbound velocity, 124,000 miles per hour, far exceeding what a long-lived comet would carry. More troubling was the outbound projection. Using the earliest orbital parameters, the object should arc around the Sun and escape carrying the memory of our star but leaving no lasting imprint. But revised models suggested otherwise. Its speed would decrease, its trajectory would bend more tightly than expected. It might not depart the solar system at all. Instead of a flyby, it appeared poised to become a fixture, as though captured or capturing itself into a solar orbit. That implication spread quickly through astronomer communities. On encrypted researcher forums, theories blossomed disciplined yet uneasy. Some pointed toward the Yarkovsky effect, speculating that uneven solar radiation might be changing the object's motion. But without signs of heat-driven outgassing, the idea held little ground. Others invoked hypothetical interstellar ice compositions unknown to science. A few quietly wondered whether the object could be fragmenting internally in a way that redistributed its mass, though the light curves showed no such behaviour. And then there were those who said nothing at all, the ones who stared longest at the orbital graphs, the ones who did not wish to speak the words forming in their minds, the ones who understood perhaps earlier than anyone else that some trajectories are not born of chance. By late detection, several space agencies had begun to aim their instruments toward the object. Deep space tracking networks gave it priority in their scheduling. Amateur astronomers contributed thousands of observations, each helping refine the arc of its descent toward the Sun. As its brightness increased, so did the sense of narrative inevitability that seemed to accompany it. The closer it came, the more its path appeared deliberate, as though guided, as though steered. Still, the formal language of discovery maintained its mask of objectivity. Agencies published neutral bulletins. Observatories issued numbers. No one dared claim design or intent. But beneath the professional caution, a quiet fear stirred that the solar system, once considered a realm of predictable peace, was receiving a visitor that behaved not like a stray but like a ship, and yet even at this early stage the object had revealed only a fraction of the mystery that awaited. The deeper astronomers slipped into the early data surrounding 3i Atlas, the more urgently a single truth pressed against the boundaries of established physics. This object was not obeying the quiet, predictable rules that govern natural wanderers from interstellar space. It was as though a shadow had entered a room meant only for sunlight disrupting the calm without announcing the source of the disturbance. The numbers did not rebel loudly. They misbehaved softly with a kind of elegance that made the deviations more unsettling than if the object had erupted with cometary violence. Slowly one anomaly folded into the next, forming a structure of inconsistencies that no natural explanation could easily contain. The first strangeness was deceptively simple. When astronomers examined the inclination measurements with increasing precision, the alignment with the solar system's ecliptic plane became irrefutable. The vast majority of interstellar objects approach from arbitrary angles, arriving like stray stones hurled from the galaxy's distant furnaces. Their motions respect the gravitational choreography of no star, no system, no orbit. But 3i Atlas behaved as though it had been shaped by an invisible hand, one that arranged its arrival along the flattest, most ordered plane available. An interstellar object matching the ecliptic within 5 degrees is a numerical miracle so rare that probability itself buckles beneath it. This was no casual drift. It was a precision arrival, and still this was only the beginning. Its brightness curve, initially smooth and puzzle-like, deepened with every observation. Natural comets exhibit chaotic flickering due to irregular rotation and shedding of volatile materials. Even the most stable of them shimmer with some degree of asymmetry. Yet 3i Atlas returned a nearly perfect signal, as though sunlight reflected across an evenly distributed surface. Its rotation period derived from these fluctuations hovered near a value that suggested intentional moderation. Not too fast for debris, not too slow for a solid ice body. It spun with the balance of something designed to remain stable during long travel. Then came the mass contradiction. As the object swept near Mars, 3 missions, NASA's Mars Reconnaissance Orbiter ES's Mars Express, and China's Tianwen-1 held vantage points that could have yielded precise gravitational readings. These measurements were critical. They would confirm whether the object was as dense as the sunlight scattering off it suggested. Yet the gravitational influence it exerted was faint, so faint that for its size it bordered on the impossible. A body of that diameter reflecting that amount of light should have registered clearly in the orbital perturbations of nearby spacecraft. Instead, it behaved like a shell, large reflective but almost empty within. A natural object of such volume cannot possess so little mass without fragmenting, spinning wildly, or collapsing under its own structure. The implications were stark, hovering unspoken in the minds of those studying it. Hollow bodies of that scale are engineered, not formed. For days, research teams attempted to reconcile the discrepancy by proposing exotic compositions, ultra-porous aggregates, aerogel-like planetary leftovers, or ancient rubble piles held together by improbable cohesion. But physics resisted these inventions. No natural process crafts a mountain-sized object so hollow that its gravitational pull nearly vanishes. This singular anomaly became the fulcrum upon which the rest of the data pivoted. If 3i Atlas was hollow, the doorstep to an entirely different interpretation opened, one that many weren't ready to confront. Next came the reflective behavior. Spectroscopic analysis failed to detect the usual signatures of water ice, carbon-rich dust, or metal-laced minerals found in deep space objects. Instead, the reflectance spectrum hinted at something smoother, more uniform, neither perfectly metallic nor comfortably mineral. Like a surface composed of layered material, thin, resilient, and resistant to solar heat. If it were natural, it defied known categories. If it were not, then its surface behaved exactly as one might expect from an interstellar craft designed to endure radiation, micrometeoroid strikes, and eons of vacuum strain. But perhaps the most intimate strangeness lay in its silence. No outgassing jets, no tail, no sublimation as it crossed temperature thresholds where ice should boil away. Comets announced their identity through violent transformation when touched by sunlight. Yet 3i Atlas maintained its shape as though light were an old companion. The absence of thermal response troubled thermal physicists. The object should have reacted visibly to rising solar flux. Instead, it acted like something accustomed to the journey, and still deeper anomalies waited. The object's trajectory incorporated subtle adjustments, tiny deviations too deliberate to be random. These were not the erratic shifts of a comet shedding material, nor the chaotic swerves of a tumbling shard buffeted by solar wind. Instead, the course corrections resembled the refined nudges produced by controlled propulsion. The changes were minuscule, nearly drowned in noise, but present. Over time, these faint shifts compounded into a path that curved with the exact precision necessary to bring it behind the sun at the precise moment of highest velocity. That razor-thin timing was the detail that snapped many astronomers into silent contemplation. To exploit the sun for velocity modification to use the Oberth effect as spacecraft do requires an engine burn at the moment maximum gravitational acceleration is achieved. This is not a process nature performs, it is a strategy, a technique, a maneuver. And 3i Atlas was positioned to execute it with perfection, descending toward a perihelion that would darken it from every instrument on Earth. If it fired a controlled thrust behind the sun, no one would see it. The mathematics painted a picture more disturbing. With each update, the object was poised to change from a hyperbolic unbound interstellar arc into a closed orbit around the sun, a permanent installation, a resident rather than a passerby. The only missing ingredient was a precisely timed injection of momentum, something only a machine or a guided structure could perform. The scientific community felt the tension growing, a tension that rippled not through the public first, but through the quiet, windowless rooms where raw telemetry was examined. People leaned closer to screens. They reread the datasets. They asked whether noise could imitate intention, whether natural processes could weave this tapestry of precision by coincidence alone. But nature does not conspire toward intention, and coincidence rarely builds itself layer by layer into something that resembles design. Even so, no one spoke the conclusion aloud. Not yet. The anomalies accumulated like soft, deliberate knocks on the door of our understanding, gentle enough to dismiss individually, but overwhelming when considered together. 3i Atlas seemed to be preparing for something. Perhaps a maneuver, perhaps a release, perhaps an arrival. Whatever the case, the scientific rules it appeared to violate were not shattered through chaos, but through grace-precise, patient distortions of what a natural object can be. And as it drifted deeper toward the sun's blinding boundary, the strangeness did not fade. It grew, becoming the quiet center of an unfolding mystery that threatened to rewrite the nature of visitation itself. Shadows glided across the red world when 3i Atlas brushed past Mars, an encounter that should have yielded clarity, yet instead carved a deeper wound of uncertainty into the scientific narrative. It was here in the cold, thin Martian orbit that humanity possessed its most capable silent witnesses: NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express, and China's Tianwen-1. Each spacecraft carried instruments delicate enough to sense minute gravitational tugs, subtle shifts, faint thermal emissions, any signature revealing the nature of the object passing nearby. And yet when the opportunity arrived, the cosmos answered with a profound, inexplicable quiet. The first hint of strangeness arose from the gravitational readings. When a body of significant size passes near a spacecraft, however faintly its mass makes itself known, the local orbit of the craft quivers, its momentum adjusts by fractions, and the telemetry whispers of the encounter. But as 3i Atlas glided past Mars, the orbiters registered almost nothing. Some measurements returned values so small they bordered on instrumental noise. Others suggested perturbations in the wrong direction, as if the object were lighter than dust, lighter than expectation allowed. A structure large enough to reflect sunlight across millions of miles should not slip past satellites without leaving a gravitational fingerprint. But that's precisely what it did. In mission control rooms across 3 continents, analysts replayed the data, dissecting it line by line. The brightness suggested an object of considerable size. The lack of gravity suggested almost no mass at all. These two facts were incompatible, yet neither could be dismissed. In physics, contradictions demand resolution, but nature in this moment offered none. Then came the silence from the imaging instruments. The Mars Reconnaissance Orbiter should have resolved some fragment of detail, an outline, a distortion, a bright region stretched by motion. The high-rise camera, capable of photographing the tracks of Martian dust devils from orbit, could have recorded the shape of the visitor had it been granted opportunity. But the images were incomplete, sparse, released in staggered intervals, none of them revealing the structure with clarity. Agencies cited various issues: solar glare, unfavorable geometry, thermal protection modes. Each explanation was plausible on its own, yet the collective pattern felt orchestrated, as though the solar system itself were conspiring to obscure what passed before the cameras. Yet the most revealing information came from the absence of gravitational pull itself. For some teams, the lack of perturbation carried a disturbing implication: hollow geometry. If the object's exterior was merely a thin shell, large in volume but negligible in mass, then conventional expectations of density simply would not apply. And if it were hollow, the question emerged like a cold breath over ancient dust. What purpose does such a structure serve? Nature does not produce hollow mountains of ice. Even comets composed of loosely bound rubble possess enough internal mass to distort nearby trajectories. Their porous interiors do not negate gravity. Their chaotic assemblies do not collapse into geometries that mimic engineered architecture. Yet 3i Atlas defied all known categories, wearing the appearance of a large object while exerting the gravitational presence of a small one. For days, researchers proposed increasingly exotic explanations. Some suggested hyperporous ice so airy that its density approached that of smoke. Others proposed a fragile collapse material structure formed from ancient interstellar collisions. But even these hypotheses fought against their own foundations. A structure as fragile as foam should have disintegrated long before crossing into the inner solar system. Radiation micrometeoroid impacts thermal gradients. Any of these forces should have shredded a lightweight body weakened by extreme porosity. Yet this object remained intact, rigid, almost serene in its passage. The next anomaly appeared in the reflected spectrum. While the telescope data from Earth had already hinted at an unusual surface composition, the readings from Mars-based sensors added sharper resolution. The material seemed to display a reflectance curve inconsistent with minerals, ices, or metallic ores commonly found in natural bodies. Instead, the curve showed a narrow controlled range, something reminiscent of layered composites, engineered to withstand extreme environments. It did not behave like rock. It did not behave like dust. It did not behave like ice. It behaved like material chosen for endurance, not formed by accident. Still many clung to the comfort of natural explanations. The mind resists the implications of the unknown. Familiarity, even when strained, feels safer than possibility. But as the data mounted, the walls of conventional understanding began to thin. One detail struck researchers particularly deeply: the thermal stability. At its distance from the Sun, 3I Atlas should have begun to warm even faintly. Cometary layers respond rapidly to sunlight, releasing vapor and dust in a process that changes brightness erratically. Yet thermal sensors aboard ESA's orbiter recorded no surge, no plume of heat, no outgassing. The object absorbed sunlight with the indifference of something designed not to react. If it had spent millennia in interstellar cold, a surge of activity would have been expected. Instead, the silhouette remained constant, as though light and heat were irrelevant to its structure. And then there was the rotation. Based on brightness fluctuations captured by Mars orbiters, analysts reconstructed a model of its spin. It was too slow for a loosely bound natural assembly. Comets tumble. Rubble piles wobble unpredictably. Yet 3I Atlas rotated with a steadiness characteristic of the mass distribution optimized for stability. There were no violent oscillations, no sudden changes in axis, no signs of structural imbalance. A natural body this hollow should not be this stable. But a constructed one could be. The combination of these anomalies drew attention from a growing number of scientists willing at least privately to consider interpretations beyond the conventional. In small conference rooms and video calls, whispers began circulating. What if the hollow interior was not a flaw but a feature? What if the structure was not the object but a shell? What if the object was not a comet at all, but something capable of enduring the cold void between stars, something designed to travel unimaginable distances without degradation? Silence from agencies only amplified the speculation. NASA cited a government shutdown for gaps in public updates. ESA referred to data processing delays. China remained silent altogether. To some, these explanations were innocuous. To others, they appeared coordinated, evasive, protective. The Martian encounter should have offered answers. Instead, it deepened the darkness around the object's identity. Every measurement intended to clarify its nature introduced a deeper contradiction. Every attempt to explain its mass, its structure, its surface, or its behavior dragged researchers further into a conceptual territory where the boundaries between natural object and engineered construct blurred beyond recognition. And in the wake of those contradictions, one possibility began to settle across the scientific landscape, like a quiet snowfall. If the object was hollow, if it was stable, if it was unaffected by heat, and if it exerted almost no gravitational influence, then it might not be a visitor sculpted by cosmic chance. It might be a vessel. What it carried or what it concealed remained hidden behind the enigmatic stillness of its passing shadow. And as it glided beyond Mars, descending toward the Sun's blinding embrace, the world's instruments prepared for what would come next, unaware that the mystery was about to deepen in ways no one was prepared to confront. As 3I Atlas slipped past Mars and continued its measured descent toward the inner solar system, the scientific world found itself caught in a quiet gathering tension. It was no longer merely the oddities of its trajectory or mass that unsettled researchers, but the way each new data point seemed to lock into place beside the last, forming not a scatter of coincidences, but a rising structure of impossibility. The mystery did not fade as the object approached the Sun. It deepened layer by layer, as though the cosmos were peeling back its veils with deliberate patience, revealing complexities timed to the object's journey inward. The closer it came, the more profoundly its behavior challenged the frameworks astronomers relied upon. The first new layer of anomaly emerged as high-resolution photometry from multiple telescopes converged. The object's surface did not behave like dust-coated ice or carbonaceous rock. Instead, it displayed a sharpness of reflectivity inconsistent with any naturally pitted or fractured surface. Light scattered from it with the uniformity of a plane, smooth uninterrupted, without the chaotic glints typically seen on irregular bodies. Some analysts attempted to attribute this to a thin frost coating, but the lack of outgassing invalidated that hope. Others proposed that the object was far smaller than the initial brightness suggested, but that explanation collapsed under thermal analysis. The surface reflectance hinted at a material that held its properties even under increasing illumination, a behaviour uncharacteristic of anything drawn from interstellar rubble. Meanwhile, as it neared the Sun's domain of intense solar wind, the expected acceleration effects remained mysteriously absent. Natural objects, especially those low in mass, are pushed, nudged or perturbed by the steady pressure of sunlight. These forces alter the trajectories of comets, asteroids and even spacecraft with measurable precision. Yet 3i Atlas shrugged off this influence. Its path exhibited no telltale drift, no deflection that would betray its lightness. This contradiction tore at the seams of conventional modelling, an object too hollow to exert gravity, yet too stable to be pushed. A paradox only resolved if one assumed internal compensatory forces, a concept far beyond the dynamics of natural bodies. Then came the spectral analysis from the infrared arrays. As it crossed regions where solar heating intensified, the wavelengths reflected from its surface remained remarkably constant. No thermal plume appeared. No radiative spike flared. Instead, the object absorbed and re-emitted infrared energy in a pattern resembling a deliberately tempered thermal signature, a signature one could expect from a structure designed to endure temperature swings without revealing its internal state. Natural objects absorb heat chaotically. This one responded like a system. Still deeper anomalies followed. As solar observatories sharpened their focus, several recorded faint oscillations in the light curve, too patterned to be random, too subtle to be rotational irregularities. These micro-variations appeared periodically with a timing that seemed almost linked to the object's proximity to sunlight flux thresholds. Some researchers speculated about internal stresses releasing energy in minuscule bursts. Others pointed toward complicated reflective interference caused by a multi-layered shell. But each explanation leaned toward desperation, reaching into the dark to retrieve rationalizations that never quite fit the data. The global scientific community began feeling the strain. In observatories around the world, researchers whispered of architecture, a word so fragile in these contexts that it was uttered only in private, and only after long hours of sleepless examination. No one wished to be the first to suggest aloud that the object exhibited characteristics of design, but the deeper each team peered into the data, the harder it became to dismiss that possibility. Then the mathematical anomalies appeared. Several orbital mechanics groups independently discovered that the object's trajectory, specifically its inward curvature, exhibited infinitesimal adjustments synchronized across different points of its path, as though responding to external factors with precision rather than randomness. Natural perturbations occur in smooth gradients, but the changes logged in 3i Atlas's course resembled corrective pulses, minute yet intentional. Each shift was too small to claim propulsion outright, yet too precise to dismiss. And over time, these micro-corrections accumulated into a trajectory that appeared ever more optimized for a specific target, the narrow corridor where the sun would render it invisible to all Earth-based observers. This deliberate threading of celestial geometry became impossible to ignore. The object was not tumbling. It was not shedding mass. It was not behaving like any comet, asteroid or ice fragment ever documented. Instead, it glided with a poise that unsettled even the most conservative of scientists. It behaved like something aware, if not in the conscious sense, then at least in the engineered sense of its environment and the need for precision in its descent. Yet the deepest layer of mystery emerged from the spacecraft orbiting Mars. Over several days, multiple instruments recorded subtle rhythmic fluctuations in electromagnetic spectra near the object, fluctuations too orderly to be natural noise. They resembled coherence patterns, faint but distinct, echoing with the regularity of a system maintaining stability or communicating internally. While the signals were too weak to classify, their structure made them impossible to ignore. What kind of object drifting unannounced from interstellar space produced patterns hinting at internal regulation? For many, the implications were too unsettling to articulate. But in the hidden corners of research forums, a hypothesis began taking shape. Not proclaimed, not published, but whispered in quiet, encrypted exchanges. What if 3i Atlas was not a single object but a shell, a container, a mother form, a vessel holding within it something concealed, perhaps dormant, perhaps waiting for a specific moment or position before acting? The more the data accumulated, the more enticing this unspoken theory became. The hollow interior implied volume, the stability implied purpose, the thermal resistance implied design, and the micro-oscillation suggested activity beneath the surface. Something inside the object might be responding to solar proximity. Something might be preparing. Secrecy from the agencies only sharpened this suspicion. Analysts noted missing windows of telemetry from several Mars-based sensors gaps that coincided with the object's closest passage. Some chalked it up to solar interference, others suspected bureaucratic delay. But the pattern felt too symmetrical, too aligned with the moments of greatest observational value. 3i Atlas moved through these uncertainties like a silent riddle, each new discovery deepening the sense that the object was not merely passing through, but performing a sequence we did not yet understand. And as it descended toward the inner reaches of the sun's domain, the puzzle sharpened into something colder, something more precise. Whatever this object was, it was not done revealing itself. The sun widened before it like a vast blinding threshold, an incandescent gate through which few objects could pass unchanged. As 3i Atlas descended toward perihelion, the tension among astronomers, physicists, and mission planners stretched taut across continents. It was not only the object's mysterious behavior that held the scientific world in a state of hushed anticipation. It was the impending moment when every instrument aimed toward it would be forced into blindness, swallowed by the light of the star. The region behind the sun, heliophysically vibrant, instrumentally lethal, observationally impenetrable, became the stage for whatever the object intended to do. And for the first time since its detection, the cosmos would fall silent around it. Days before the descent into solar concealment telescopes captured their last clear glimpses, the object's brightness intensified, but not in the chaotic shedding manner of a normal comet. Instead, it brightened with the steady amplification of a polished surface receiving increasing sunlight. There was no coma, no plume, no signal of disintegration. It simply reflected the sun with an almost serene composure. Observatories across Earth monitored its progression, but the data began to degrade as thermal interference, solar scattering, and the tightening geometry nudged the object ever closer to the sun's unforgiving glare. The Parker Solar Probe, already engineering its own daring approach into the sun's corona, briefly became humanity's best hope for continued observation. Its sensors hardened for environments where plasma streams burst like molten wind, could record electromagnetic shifts and particle flows even when ordinary telescopes went blind. But even Parker could not see the object directly. It could only sense disturbances, patterns, anomalies. It became a stethoscope pressed against the beating heart of the star, listening for anything unusual. Meanwhile, on Earth mission control centers prepared for the blackout. Observers updated orbital projections with increasing frequency, trying to predict the exact moment the object would vanish behind the sun. Simulations played endlessly on monitors' lines of trajectory curving in a precise arc that threaded through the sun's blinding sphere. If 3i Atlas were intending to exploit the Oberth effect, this was the corridor where it would occur. A maneuver executed at maximum gravitational velocity would alter its path by an amount no natural object could achieve. And the moment of that maneuver, the critical instant, would unfold completely hidden from every telescope, radar, and sensor residing on the near side of Earth. The final hour before disappearance was marked by a peculiar stillness in the scientific community. Teams who had spent weeks debating mass anomalies and spectral mysteries now found themselves simply waiting for the object to pass into a region where certainty ended and speculation began. Even seasoned astronomers trained in disciplined detachment felt an unspoken tremor. It was not fear exactly, nor hope. It was a quiet acknowledgement that something old and vast was about to slip into a veil where no human eye could follow. At the moment the object crossed into the sun's blinding envelope, observational streams went dark one by one. Data feeds flattened into static. Space-based sensors reached their safety thresholds. Telescopes on Earth, previously straining against the edge of solar exclusion zones, closed their shutters. For the first time since its discovery, 3i Atlas existed entirely beyond human measurement, moving through a realm where only the sun's internal storms could witness its passage. In that invisibility, the mystery deepened. For several hours no data came, not even ambient noise. The object's expected trajectory placed it within a region where solar radiation surged chaotically, pulsing with magnetic turbulence. Any artificial mechanism within the object, if such a mechanism existed, might be shielded or might activate under these conditions. But with no direct observation, speculation swelled into the quiet corners of scientific thought. Then one instrument spoke. At 3:12 a.m. UTC, the Parker Solar Probe registered an abrupt spike, an electromagnetic burst lasting 7 seconds. It rose sharply above the background flux and then fell, vanishing as quickly as it appeared. The official explanation, when released later, attributed the event to data corruption from high-intensity solar activity. But among the teams analysing the readings, something felt misaligned. The timing was too precise, the duration too clean, the signal too compact for random noise. The burst coincided exactly with the moment the object reached perihelion. If the object had fired propulsion, if it had adjusted its velocity in the precise instant necessary to exploit the Oberth effect, this was the moment it would have done so. The energy signature of such a maneuver, while likely shielded, might still express faintly through the cloud of plasma and magnetism surrounding it. And the recorded burst? Fit. But without direct confirmation, the question lingered like a low hum across the scientific world. Had the object performed the maneuver? Had it altered its fate, binding itself to the solar system? Or had it passed unchanged, simply slipping into the brilliance of the star and out the other side, destined to return to the interstellar dark? In the absence of data, imagination flourished, not the fanciful imagination of fiction, but the disciplined imagination of scientists confronting the edges of their known world. Some envisioned a natural object adjusting its path through unknown physics. Others imagined an engineered shell completing a planned braking sequence, and a few quietly pondered whether the object was not the traveller at all, but the courier carrying something that would awaken only once hidden from observation. As the hours passed and the world waited for re-emergence, the sun radiated its usual unbroken brilliance, indifferent to the secrets passing behind it. The silence became a presence of its own, an invisible blanket tightening around the moment when humanity would discover whether the object emerged intact, altered, fragmented, or accompanied by something new. The light was bright, the wait was long, and the solar system held its breath. The moment 3i Atlas vanished behind the sun, the world entered a strange suspended interlude, a pause between what had been observed and what was now only imagined. Yet even as the object passed through the star's blinding shadow, its trajectory continued to haunt the minds of those who had spent weeks unravelling its behaviour. One principle in particular loomed above all others: the Oberth effect. It had hovered over every discussion, every simulation, every late-night calculation scrawled across chalkboards in dim university offices. Now, as the object crossed the very point where this effect became most potent, the implications of that manoeuvre, if executed, felt almost unbearable in their weight. The Oberth effect is not a metaphor nor some esoteric footnote in astronautics. It is a cornerstone of deep space propulsion. When a spacecraft fires its engines at the moment of maximum velocity, usually near a planet or star's closest point, it harvests the gravitational acceleration to amplify the thrust. A small burn made at perihelion can translate to an enormous shift in outbound velocity. Humans have used it to fling probes toward the outer planets, shaping trajectories that would otherwise require impossible fuel reserves. But nature does not use the Oberth effect. It cannot. There is no biological, chemical, or gravitational mechanism that allows a natural object to release a precise burst of energy at the exact microsecond of maximum speed. No comet, no asteroid, no interstellar fragment drifts into the sun's furnace and decides at that moment to change its fate. Only engineered entities can make such a decision. And so, as 3i Atlas moved into the sun's radiance, the possibility that it would perform an Oberth maneuver hovered in the minds of observers like a quiet spectre. The incompleteness of the data, interrupted by the inevitable glare, left only one window of detection: indirect signals from the Parker Solar Probe. Yet even that craft, shielded against the sun's brutal breath, could detect nothing visual. Only electromagnetic echoes, particle shifts, plasma turbulence. Only whispers. The 7-second spike it captured was subtle, but its significance was enormous. Though publicly dismissed as anomalous data, its timing aligned with uncanny precision. To those who understood orbital mechanics, the spike felt like a signature, a pulse, a whisper of intent emerging from behind the veil of solar fire. If 3i Atlas had executed the maneuver, its entire nature changed in that moment. No longer unbound, it would become a solar satellite, an interstellar visitor choosing to stay. Simulations run in the hours before re-emergence delivered predictions of profound divergence. In some, the object continued its hyperbolic trajectory unchanged, destined to exit the Sun's dominion forever. In others, the arc tightened dramatically, transitioning into an elliptical orbit that would inject it into the inner solar system with periodic returns. But the most unsettling projections were the ones that suggested the object might not simply orbit the Sun, but might stabilize itself using repeated micro-adjustments to settle into a path optimal for long-term observation of the planets. A natural comet would never choose such a path, but a probe might. This was the silent terror of the Oberth possibility. If the object had used the maneuver intentionally, then its arrival had purpose. Its presence was not random. It had come not to pass through, but to enter, to remain, to take up residence in the gravitational well of our star, where its vantage point would provide unbroken access to the unfolding clockwork of the solar system. Engineers who worked on spacecraft propulsion found themselves staring long into the perihelion models. The burn required would not be large, just a precise nudge, perfectly timed, perfectly oriented. A few seconds of controlled thrust at the peak of velocity would be enough to bind it here permanently. It was the kind of maneuver human spacecraft execute with careful planning and massive engineering effort. Yet the object had shown no visible engines, no heat vents, no exhaust. If it had propulsion, it was hidden shielded or operating at a scale invisible to conventional measurement, and so the scientific world waited. Hours turned to a day turned into 2. Telescopes checked and rechecked their coordinates. Instruments recalibrated. Agencies issued careful statements emphasizing patience. But beneath the formal restraint lay a deeper urgency. The object would reappear, or it would not. Either outcome carried implications that would ripple across the foundations of astronomy and physics. If it reappeared along its original expected outbound path, then perhaps it remained a natural visitor, strange but comprehensible. If it emerged along a dramatically altered course, then something extraordinary had occurred behind the light. And if it did not reappear at all, then the solar system had acquired a new inhabitant that now drifted somewhere no telescope could yet trace. In the long silence, countless minds returned to the same question. Why would any object, natural or artificial, perform such a maneuver? The logic of an interstellar traveller breaking into orbit around a star is profound. A permanent presence would allow systematic observation, prolonged data gathering, stable positioning, a vantage point from which planets could be monitored over decades, centuries, a steady sentinel residing within the heliosphere studying a system not its own. And yet the question that mattered most bloomed quietly in the depths of scientific contemplation. Was the object alone, or was the maneuver a preparation? Theories multiplied in quiet academic channels. Some suspected the object could eject smaller units once in a stable orbit. Others speculated that a shell-like structure could unfold or release internal components, shielded from solar detection. And a few, drawing on the disturbing anomalies already recorded, wondered whether the object itself was not a visitor, but merely the carrier, its true contents dormant stored, or awaiting the right environmental threshold. The sun's veil held its secrets with impenetrable clarity. No human eye could pierce the inferno. No lens could cut through the plasma. Whatever happened behind that radiance would remain untold until the object emerged once more. And so the world waited poised between the known laws of physics and the creeping suspicion that something on the other side of those laws was preparing to take its next step. For nearly 3 days, 3i Atlas remained hidden, submerged behind the sun's blazing curtain, sealed away from every telescope, every sensor, every line of sight humanity possessed. It was a silence that did not feel empty. It felt charged, as though the darkness into which the object had slipped was not absence, but preparation. By the time the object approached the far edge of the solar disk, teams across the world were operating on little sleep, their screens filled with simulations and models trying to predict what would re-emerge. What they expected was uncertainty. What they received was something far stranger. The first sign that something had happened behind the sun was not visual at all. It was the spike-sharp, sudden and unnervingly precise recorded by the Parker Solar Probe at 3:12 a.m. UTC on the second day of the occultation. The burst had lasted only 7 seconds, but its clarity was unmistakable. It rose far above the ambient electromagnetic noise, forming a clean, narrow-profile signature before vanishing. On paper, it looked artificial. In practice, it resembled nothing Parker had ever recorded in its many orbits around the Sun. Public statements attempted to bury it. NASA labeled the spike a data corruption artifact, attributing the anomaly to high solar flux saturating Parker's instruments. To most, especially those outside the field, the explanation was enough. But inside the scientific community, among plasma physicists, spacecraft engineers, and those deeply familiar with Parker's operational tolerances, the dismissal felt uneasy. Data corruption from solar storms is chaotic by nature. It blooms irregularly, leaving messy fingerprints across multiple instruments. But this spike was clean and contained almost surgical in its isolation, and its timing aligned too precisely with the object's perihelion. If 3i Atlas had executed a maneuver, if it had fired an engine, deployed an internal mechanism, or activated a system, this was the moment it would have done so. The silence that followed grew heavier. Then came the flicker of confirmation. Ground-based observatories in Chile, Spain and Australia captured their first faint images as the object slipped from behind the sun's blinding edge. At first the signals were weak, just points of brightness against the sky. Teams scrambled to refine their optics, adjust their filters, recalibrate their tracking systems. Within minutes the faint smear of light began to sharpen, and then a gasp rippled across one control room after another. It was not one object that emerged, it was several. At least 7 distinct points of reflected sunlight glided into view, trailing in a loose-ordered formation. Their spacing was too consistent to be random, their velocities too synchronized to be fragments drifting aimlessly. They moved with purpose, motion governed not by chaotic breakup but by coordination. Natural comets fragment explosively, scattering debris outward in a chaotic spray. Their remnants fall into disarray, tumbling unpredictably. They do not separate into clean, evenly distanced bodies moving in locked step geometry. But here they were, a constellation of siblings orbiting a parent body or perhaps departing from it entirely. The shape of the primary object also appeared altered. Once a single point of light, it now reflected in a way that suggested a hollowed silhouette. Its brightness diminished as though a portion of its mass had been redistributed. In small observatories and major space centers alike, the reaction oscillated between stunned silence and frantic recalculation. The trajectories of the smaller bodies were plotted instantly. Some drifted outward in slow arcs, others accelerated slightly as though guided along branching paths. One of them, labelled Fragment B, appeared to follow a vector leading roughly toward Earth's orbital route. No one knew what to call them. Fragments felt inaccurate, fragments drift and scatter. These moved as though deployed. The Earth-based telescopes could not yet provide detail, but as the objects brightened, their motion carried evidence of deliberate arrangement. Their relative distances remained stable. Their divergence angles appeared mathematically regular. A few teams whispered the term formation, though no report dared include the word. Still, the object continued its emergence. By the time the Solar Dynamics Observatory captured its first infrared pass, the picture had sharpened enough to confirm a second anomaly. The smaller objects were not changing temperature. They did not flare as comet fragments do. They did not absorb or emit heat in a way typical of natural bodies. Instead, they maintained thermal signatures almost identical to the parent structure, flat, controlled, as though governed by internal regulation. The Parker Solar Probe's earlier data spike now seemed less like corruption and more like a clue. If the primary body had expelled smaller units during perihelion units, designed to activate only after emerging from the sun's cover, then the electromagnetic burst might have been an operational signature rather than a flaw. This possibility circulated privately among research groups in coded language, careful phrasing. No one wanted to announce speculation without proof, yet the alignment of evidence forced the question into every conversation. Had 3i Atlas released something behind the sun? Photos continued to sharpen. Each new image chipped away at denial. The purported fragments held shape instead of disintegrating. Some appeared to adjust their orientations as they travelled. One changed velocity slightly, too slightly for a chaotic fragment, but precisely enough for autonomous correction. The object had not broken apart, it had multiplied. The implications radiated outward like ripples from a stone dropped into deep water. If these smaller bodies were probes, then the solar system had just received a distributed network of devices whose intentions were unknown. If they were instruments, then their coordinated trajectories were the beginning of a survey. If they were seeds, as some theorists dared whisper, then the parent body had successfully executed a deployment maneuver hidden by the sun's glare, and the silence from major agencies only deepened the unease. Statements were cautious, vague, hedged by qualifiers. No images were released immediately. No high-resolution datasets were published. Some agencies went completely quiet. For the first time since its discovery, 3i Atlas no longer felt like a singular mystery. It felt like the opening move of something larger. The break behind the sun had not been a simple disappearance. It had been an event, and now as the objects fanned out across space, humanity had no choice but to watch, to wait, and to recognize that the solar system so long imagined as a quiet, predictable domain had just become the stage for a mystery that was no longer hiding behind the sun. It was advancing into the light. The first clear image capturing the newly emerged constellation of objects spread through the astronomical community with the force of a quiet shockwave. For weeks, researchers had braced themselves for anomalies, but not for this orchestrated geometry, this calm procession of bodies drifting outward from behind the sun like a formation emerging from behind a curtain. Even at low resolution, the structure of their movement was undeniable. These were not shards of a disintegrating comet nor remnants of explosive fragmentation. They moved with the intimate synchronization of entities that shared a common origin and a common directive. As telescopes across Earth refined their focus, the patterns sharpened. 7 discrete objects were now visible, each tracing a path distinct yet mathematically related to the others. Their spacing remained uncannily consistent. Their angular velocities aligned within degrees of precision no natural breakup could achieve. And most troubling of all, they appeared to orient themselves not randomly, not chaotically, but in relation to one another. Formation. It was a word few dared to use publicly, though it hovered in every private meeting, every internal memo, every whispered exchange between astrophysicists stunned by what they were witnessing. Because formations are not accidents. Formations are not born of physics alone. Formations imply coordination. The parent object still labelled 3i Atlas, continued along its projected path, though its reflectivity had altered, dimming slightly, as though an internal chamber had been emptied, or a portion of its shell had been released. Its motion remained stable, suggesting that whatever mechanism had deployed the smaller entities had not destabilized the shell. This stability, combined with its feather-light gravitational signature, supported the hypothesis that it was hollow, thin-skinned engineered for transport rather than mass. But the smaller objects were different. Fragment B accelerated ever so slightly, taking a path that would intersect Earth's orbital plane in a matter of weeks. Fragment C drifted toward Mars. Fragment D moved outward toward the asteroid belt. Others fanned out at angles consistent with a deliberate dispersion pattern, covering a variety of solar latitudes and trajectories as though sampling the environment or positioning themselves for long-term observation. This was not random drift. This was distribution. Within hours of their detection, radar arrays began sweeping for reflections. The signal from Fragment B returned first, offering the clearest evidence yet that what the world was observing defied every natural category. Its radar cross-section was not jagged or diffuse, but sharply defined like a smooth geometric structure reflecting with uniformity. Natural debris scatters radar in chaotic, unpredictable patterns. This object returned a signature consistent with polished material, flat planes, sharp angles, intentional design. That discovery jolted the astrophysical community. Private channels flared with messages, reflectivity gradients too clean, specular return, impossible for natural ice geometry confirmed. And though no official statement acknowledged it, the teams involved understood what they had seen. The objects were metallic. As the fragments continued to brighten in the days following their emergence, another anomaly became impossible to ignore. None of them tumbled. Natural fragments, especially those with irregular mass distribution, spin chaotically after separation. But each fragment from 3i Atlas maintained a controlled orientation, rolling slowly, adjusting as though following internal gyroscopic regulation. The comparison to spacecraft became unavoidable. Data from the European Southern Observatory revealed yet another detail: the fragments did not drift apart as gravitational and kinetic dispersion would normally dictate. Instead, they maintained relative positioning in a way that resembled nothing less than an intelligent distribution network, a pattern that mirrored certain terrestrial satellite deployment strategies. Scientists began calling the formation the chain, though unofficially. It described the subtle, coordinated arrangement the fragments adopted, a curved arc, fanning outward from the parent body, but not spreading too thinly or too wide. The geometry hinted at an underlying logic, a mathematics of placement that appeared optimized for coverage, for redundancy, perhaps even for communication between units. Infrared sensors from multiple observatories soon confirmed still more unsettling characteristics. The fragments emitted no excess heat. They did not warm under solar flux. They regulated temperature with the composure of objects insulated or shielded by advanced materials. And strangely, some appeared to adjust their albedo slightly, as though modulating reflectivity in response to the changing solar angle. Natural fragments cannot alter their surface properties dynamically, but engineered structures can. The world had not fully grasped the implications. The data had not yet been made public. But in research facilities scattered across Earth, Cambridge, Pasadena, Munich, Tokyo, a quiet and growing certainty crept into the room. This behavior was unprecedented, inexplicable by geology or physics alone. Still, the most profound anomaly had yet to be revealed. During the hours following their re-emergence, the Deep Space Network, scanning the vicinity of the fragments, detected faint narrowband signals repeating pulses of electromagnetic energy, spaced at exact intervals. Too structured to be noise, too regular to be cosmic background interference. Though weak, they aligned precisely with the position of the fragments. Not continuous transmissions, pings, rhythms, bursts. It was Fragment B heading roughly toward Earth's orbital path that emitted the strongest pulses. Not data in the way humans encode it, but patterns like a beat, a pulse, a metronome tapping across the void. Early Fourier analysis revealed harmonics inconsistent with random phenomena suggesting intentional modulation. But the signals were not aimed at Earth. They were aimed at the other fragments. A network, a system, a constellation awakening. This was the point at which many scientists, even the most conservative among them, felt the ground shifting beneath their theories. In the official channels, the language remained cautious. Instrumental anomalies, unconfirmed readings, possibly natural phenomena. But in private, those who examined the raw telemetry understood what they were facing. A deployment had occurred behind the Sun. A system of objects now travelled within the solar system in a coordinated network, and the era in which humanity assumed it was alone had quietly, silently ended. What the fragments intended, what their formation signified, what their trajectories foretold remained shrouded. But the universe had delivered something into the inner system, something that behaved not like a visitor, not like debris, but like a presence now fanning out through the light. By the time the fragments were fully catalogued and their trajectories mapped, a new and deeply unsettling truth had emerged. These objects were not only moving with intention, they were behaving like machines. The evidence accumulated piece by piece, each data point sharpening the silhouette of something unprecedented drifting through the inner solar system. What had begun as a hollow anomalous visitor had now multiplied into a constellation of entities that demonstrated characteristics no natural body could imitate. The first indication came from radar returns captured by the Goldstone Deep Space Network. Fragment B, already the most closely monitored due to its Earth-crossing trajectory, produced a signal unlike anything researchers had expected. Instead of the diffuse, grainy reflection characteristic of icy or rocky debris, the echo came back sharply defined, smooth, geometric, as though the radar pulse had struck flat surfaces, angled planes or contours engineered to reflect in predictable ways. Such clarity could not be explained by natural formation. Even asteroid surfaces, when unusually smooth, produce irregular radar scattering due to microscopic roughness. But Fragment B returned a signature with the consistency of polished alloy. Within hours, multiple stations confirmed similar results for other fragments. Fragment D, moving toward the asteroid belt, produced a radar profile that suggested a hexagonal symmetry. Fragment F returned oscillations consistent with internal cavities or structural ribs. Fragment C revealed the faint resonance pattern of a hollow shell, smaller, denser, and far more symmetrical than debris of its size should ever be. Combined, these signals formed a tapestry of engineering-like traits: uniform reflectivity, defined edges, internal emptiness, precise mass distribution. Something had built them. Still more anomalies emerged as optical telescopes provided clearer images. Under magnification, the fragments exhibited peculiar behavior. They oriented themselves, not randomly, not chaotically, but in response to solar angles, to motion, and even to one another. Small adjustments in attitude, subtle, measured rotational shifts suggested some form of internal stabilization. Natural fragments tumble. These rolled with the grace of objects that understood balance, but it was their thermal behavior that rattled even the most skeptical scientists. When objects travel near the sun even briefly, their surfaces heat unevenly. Dark patches flare with infrared radiation. Bright patches scatter light unpredictably, and any small object of metal or ice would reveal hotspots or cooling zones as it adjusted orientation. Yet these fragments displayed none of that. Their infrared signatures remained astonishingly stable. They absorbed heat with a uniformity that implied insulation or active thermal regulation. No hotspots, no thermal shedding, no emission spikes. The signature resembled the flat controlled temperature regulation of a satellite designed to endure exposure without betraying its internal structure. All of this forced a new conclusion into focus, one that no natural interpretation could sustain. These were machines without precedent. Even their trajectories reinforced the conclusion. Natural debris drifts unpredictably influenced by microgravity, solar wind and spin momentum. But these fragments moved with the poise of navigation. Over the first week following their emergence, astronomers detected minute course corrections, each fragment adjusting ever so slightly as it diverged from the parent object's path. The adjustments were consistent with autonomous propulsion. Not thrusters, not in any visible or thermal sense, but microforces, as though the objects interacted with solar radiation, or magnetic fields, or some inertial mechanism unfamiliar to known physics. Fragment B performed the most dramatic demonstration of autonomy. As it drifted inward toward the Earth's orbital trajectory, its orientation shifted subtly but definitively, as though presenting a face toward the sun, then rotating again as it passed through a region of high solar flux. It was not tumbling, it was steering. Telescopes in Australia, Spain and Japan captured sequences showing the object stabilizing itself in relation to its own velocity vector. The data stunned engineers. This was the kind of behavior performed by spacecraft with active attitude control systems, devices that sense their position and adjust themselves to maintain stability, and yet it emitted no heat, no jets, no visible energy plume. Whatever mechanism guided these fragments worked silently, gracefully hidden beneath surfaces that refused to betray their design. But perhaps the most jarring discovery came from the signal analysis team studying the narrowband pulses detected earlier. The pulses repeated in harmonic intervals, not noise, not static, not random cosmic interference, a pattern that repeated with algorithmic precision. More troubling, several fragments were now emitting pulses in intervals that matched a synchronized communication network. Fragment A, the parent, transmitted once. Fragments B and C responded seconds later. The pattern circulated through the constellation like a whispered instruction passed from node to node, a machine language with no decoder. The pulses were rhythmic, not data-rich like a heartbeat or a ping or a synchronization clock. They did not aim at Earth. They aimed at one another. Within the first week, researchers noticed something else: the pulses were tightening. The intervals shortened. The clarity increased. The signals grew faintly stronger. The network was calibrating itself. This realization spread through research communities like a cold wave. The fragments were not inert. They were not drifting relics. They were active. They were adapting. They were initializing a system. A distributed system. A constellation. A swarm. Scientists began asking questions they had never needed to ask before. What power source sustained these objects? How had they survived interstellar cold? Why deploy near the sun? Why distribute into separate trajectories? What was the purpose of Fragment B's inward drift toward Earth's orbital corridor? Even conservative researchers, those who clung longest to natural interpretations, felt their confidence falter. Something unprecedented had arrived in the solar system. Something hollow. Something deliberate. Something that had now revealed its pieces. The fragments did not behave like shards of ice. They behaved like instruments. Machines. Devices awakening from a long sleep beneath a shell that had carried them across the interstellar dark. The mystery of Three-Eye Atlas had transformed into something far more profound. The solar system was no longer receiving a visitor. It was receiving a presence, and that presence was now preparing its next movements. Long before the fragments completed their first full day beyond the sun's glare, a theory that had once lived only in speculative corners began resurfacing with new and uncomfortable relevance. It came not from a fringe of science, but from one of its most outspoken and rigorous thinkers, the dandelion seed hypothesis proposed years earlier as a framework for how an advanced civilization might explore the galaxy. It suggested that instead of a single monolithic craft crossing the interstellar gulf, a hollow parent vessel, lightweight, durable and engineered for endurance, could carry within it a multitude of smaller probes. These would be released only upon reaching a target system, fanning out in purposeful directions like the drifting seeds of a dandelion carried on a cosmic breeze. When 3i Atlas first appeared, the idea seemed unnecessary and extravagant speculation reserved for those willing to entertain the possibility of design. But now, with 7 smaller objects emerging behind the Sun, in stable, controlled paths, the hypothesis no longer stretched imagination. It simply described what was unfolding. If the object had indeed been a carrier, then the moment of perihelion hidden from all observation was not simply a turning point in its orbit. It was the moment of release, and the fragments now dispersing across the solar system were not debris. They were emissaries. The deployment pattern carried all the hallmarks of intention. Not random scattering, not explosive fragmentation, but a sequence optimized for distribution. Some moved inward, some outward, some along the ecliptic plane, others shifted above or below it. The result resembled a scanning net drifting across the inner system, sampling environments, gathering information, perhaps communicating among themselves. A network of seeds, but the deeper significance lay not merely in their coordinated trajectories, but in the broader logic they suggested. If an advanced civilization sought to explore distant stars, it would not dispatch crude vessels. Those were far too slow, too costly, too fragile for the long sweep of cosmic time. Instead, it would send automatons durable, long-lived, capable of self-repair and adaptation. And if those automatons required stealth survival or prolonged stasis, they would be stored inside a hardened shell, a hollow carrier able to cross interstellar distances with minimal energy expenditure. 3i Atlas had fit that profile perfectly long before its interior revealed its contents: the hollow mass, the anomalous density, the smooth surface optimized for endurance, the stable rotation that suggested gyroscopic balancing, and now the release of internal units. Together they formed a picture that grew more complete with each new observation. 3i Atlas was not an isolated object. It was part of a larger process, a methodology, a strategy for galactic exploration. But what unsettled scientists most was not the existence of the seeds, it was their behavior. Fragment B heading toward Earth's orbital corridor signaled to the others in a pattern too orderly for noise. Fragment C drifting toward Mars appeared to adjust its velocity in response to solar flux changes. Fragment F moving outward toward the asteroid belt oriented itself toward the Sun, in a manner reminiscent of power harvesting. All were silent in the thermal sense, their heat signatures regulated with uncanny precision. Natural bodies do not behave this way, and so the question sharpened: why deploy at perihelion? Why execute the release precisely when hidden behind the Sun? If a civilization intended to observe without immediate detection, a release concealed by solar radiation would be ideal. No telescope could track the moment of separation. No observatory could witness the transition from singular object to swarm. The emergence would appear sudden, inexplicable, shrouded in the Sun's brilliance. The parent vessel would reappear altered but intact, its work already done. The timing felt engineered to exploit the one blind spot in humanity's observational capabilities, the Sun itself. This realization spread quietly through analysis teams and research communities. In private forums, physicists discussed the pattern with growing clarity. The operation was hidden intentionally. Whether the purpose of the deployed fragments was reconnaissance mapping, or something more profound, remained an open question. Their paths suggested a broad survey of the inner system. Their communication pulses hinted at coordination. Their temperature stability implied a level of technology resilient to intense solar exposure. The implications were enormous. If these were probes, then they carried sensors capable of sampling electromagnetic spectra, atmospheric chemistry, thermal gradients, planetary magnetic fields, and possibly even biological signals. They might be observing Earth-Mars, the asteroid belt, or the behavior of solar activity itself. The seeds once dormant had awakened, and yet amid the escalating wonder and fear, another possibility began threading itself through scientific debate, one that trembled on the edge between curiosity and dread. What if the hollow carrier had not simply transported probes? What if it was itself still active? Its altered reflectivity suggested internal change. Its thermal signature hinted at remaining mechanisms. Some models predicted additional smaller internal compartments, and the parent object continued moving not away, not escaping into the outer system, but stabilizing itself into an orbit that would keep it between Venus and Mars for years, perhaps decades. It had not completed its mission. It had only begun. For many observers, the philosophical implications grew heavier. The seeds did not carry weapons or broadcasts. They did not emit powerful signals or beam data toward any known destination. Their behavior was measured, subtle, restrained. They resembled the opening pages of a story rather than its climax. A civilization that could send such devices did not need to announce itself. It needed merely to place its seeds and wait, perhaps for years, perhaps for centuries, perhaps for a response. The dandelion seed hypothesis, once a metaphor, had become the lens through which the fragment's behavior was understood. And as the seeds drifted outward through the solar system, silent and inscrutable, the world began to wonder whether they were watching us, learning us, or simply taking their first quiet breath in a system newly added to their long ancient journey. Whatever the truth, the deployment marked a shift in cosmic history. The solar system was no longer alone. It had become soil. In the days that followed the deployment, an uneasy stillness settled across the scientific world. A stillness broken only when radio telescopes, deep space arrays, and optical observatories began detecting faint repeating signals emanating from the fragments. They were subtle at first, almost dismissible, like a whisper buried within a storm of cosmic noise. But as the signals strengthened and synchronized, it became impossible to pretend they were chance. Something in the fragments was speaking, if not to us, then certainly to each other. At the SETI Institute, analysts who had spent their careers listening to the cosmos for structured signals found themselves frozen over their consoles, staring at patterns they had never prepared for. Narrow band bursts, brief, meticulously spaced, cut through the noise floor with rhythmic precision. A cosmic metronome. A pulse with timing so exact that even atomic clocks drifted more unpredictably. The signals were not rich with encoded information, at least not in any way humans could immediately decipher. They were skeletal, like the heartbeat of a machine confirming its presence to its siblings. The pulses originated from several of the fragments, but most clearly from Fragment B, the same fragment whose trajectory would soon intersect Earth's orbital path. The timing of the burst formed an intricate structure, with one fragment initiating a pattern, and others responding milliseconds later, adjusting their frequency as though calibrating a shared system. This was not communication in the human sense. It was synchronization, initialization, a network coming online. Scientists mapped the cadence across time. What they found was chilling in its elegance. The intervals tightened gradually like clockwork pieces aligning. The harmonics sharpened, the pulses stabilized into a lattice of signal rhythms, and then, as if emerging from a completed sequence, the fragments fell nearly silent, emitting only occasional, almost ceremonial pings to maintain coherence. It was as though the fragments had been dormant during their interstellar voyage, awakening only upon release, checking one another's status, and then confirming their place in the network before entering some deeper operational mode. Fragments that had once appeared mute now expressed structured electromagnetic life. But the most dramatic moment came 3 nights after the initial signals were detected. A sudden clear emission surged from Fragment B, stronger, longer, more complex than anything recorded before. It lasted 22 minutes. When filtered and mapped into a numerical sequence, it revealed nothing linguistic, nothing symbolic, nothing culturally coded. Instead, it conveyed something far deeper. The first 137 prime numbers arranged in a spiraling matrix. No natural process produces such a pattern. Prime numbers are a universal signature, an unambiguous beacon recognized across all mathematical intelligence. They are not shaped by culture, not bound by biology. They speak to order, to intention, to logic, a message not in words but in truth itself. The moment the primes were mapped, observatories across the world erupted in stunned silence. Scientists and engineers faced a realization they had long speculated upon, but never truly expected this was intentional. Not an accident of plasma interference, not a coincidence of cosmic noise. Fragment B had broadcast a mathematical signal into the void, a signal as clear and irrefutable as the flash of a lighthouse on a dark, storm-thrashed coast. The world did not hear it live. No public alert was issued. The message travelled first through encrypted channels passing from research institutions to government liaison teams, then into classified corridors where the implications were dissected with rising breathless urgency. 22 minutes, one deliberate pulse, one unmistakable confirmation, and then silence, not the silence of malfunction, no chaotic drift, no change in trajectory, no collapse of signal strength. Rather a measured quiet, as if the transmission had served its purpose and was no longer required. From that point forward, the fragments behaved with greater composure. Their pulses became infrequent, spaced out across hours rather than minutes. Their orientations stabilized further. Their thermal signatures remained resolutely flat. Their internal rhythms, if they had any, remained hidden beneath the stillness of their external form. The scientific community fractured into schools of interpretation. Some believed the transmission was a calibration beacon, a test perhaps, or a synchronization pulse intended to confirm the network's functionality after deployment. Others argued it was a message meant for us, a demonstration of intelligence, a mathematical handshake, the simplest possible gesture across the abyss between minds. A third view, both more unsettling and more plausible, suggested the signal was not aimed at Earth at all. Instead, it was aimed at the parent object Fragment A, marking the completion of the deployment sequence and the readiness of the children. In that interpretation, humanity had not been addressed, had not been acknowledged, had not been considered. We were simply bystanders who happened to overhear a message never meant for our ears. Whatever the truth, the fragments gave no further messages of that scale. Yet the smaller rhythmic pulses continued steady, unwavering, the heartbeat of an alien constellation now inhabiting our solar system. And as their signals circled quietly through the dark, the once comforting silence of space felt forever changed. It was no longer the silence of emptiness. It was the silence of presence of watchers or explorers or seeds, resting in the light of our star, waiting for whatever came next. Long before the public caught the faintest whisper of what was unfolding, the world's scientific institutions and governmental agencies had already descended into a quiet storm. The revelations surrounding 3R Atlas and its newly deployed fragments were no longer curiosities on the edge of astrophysical debate. They had become matters of planetary consequence, and the weight of those implications pressed heavily against every mind tasked with interpreting the data. For decades, humanity had imagined first contact in cinematic terms, a message beamed across the stars, a spacecraft descending through clouds, a signal directed unmistakably at Earth. But nothing in those narratives had prepared the world for this, an arrival, without announcement, an unfolding network of silent machines drifting into our solar system, conducting their operations with neither hostility nor greeting. If extraterrestrial intelligence had made its presence known, it had done so not with a shout, but with a whisper too complex and too subtle for humanity to immediately understand. In research centres across Europe, Asia and the United States, emergency meetings took place in quiet conference rooms sealed from the public eye. Physicists, engineers, astronomers and military advisors crowded around projection screens, analysing every scrap of data collected since the perihelion event. Fragment trajectories, radar signatures, electromagnetic pulses, thermal stability curves, and at the centre of every discussion the prime number transmission. The prime matrix changed everything. It was, in the language of astrobiology, a universal handshake, an unmistakable artifact of intelligence. No physical process, however exotic, could generate a 137-term sequence of primes arranged in a structured spiral. It was intent made visible through mathematics, yet that intent was not directed at Earth. The realization troubled scientists profoundly. Humanity had always assumed that if intelligent life contacted us, it would do so deliberately seeking dialogue, recognition, or exchange. But the fragments had behaved as though Earth were incidental, important only in passing, observed perhaps, not addressed. This interpretation unsettled the philosophical core of the scientific world. If the fragments were not attempting to communicate with us, then perhaps they were here for reasons that had nothing to do with humanity at all. Perhaps we were witnessing an automated process, a cosmic routine, one that unfolded wherever the parent vessel drifted. A process older than our civilizations, more systematic than our sciences, and utterly indifferent to the species that happen to inhabit this star system. This possibility of indifference rather than contact struck many researchers as more terrifying than hostility. Governments worried for different reasons. In the United States, military analysts scrambled to model potential risks. Were the fragments reconnaissance devices? Could they map Earth with precision far surpassing satellites? Did they possess propulsion systems capable of reaching the planet? Were they observing technological emissions, infrastructure, atmospheric composition, or something else entirely? Something humans had not yet imagined. Reports circulated privately that Fragment B's trajectory, shifting slightly but steadily, would bring it within several 100,000 miles of Earth. Close enough for detailed observation, close enough to gather information about the planet's electromagnetic environment. Too close, some argued, to dismiss as coincidence. At the Pentagon, advisors began discussing contingency plans for close observation encounters. Similar conversations unfolded in Europe, China, India, and Japan. But the deeper these discussions went, the clearer it became that humanity possessed no tools capable of interacting with the fragments in any meaningful way. Not militarily, not technologically, not diplomatically. The fragments emitted no heat signature, offered no propulsion, plume revealed no vulnerable entry points or mechanical seams. They might as well have been perfect devices for the environments they navigated, designed not only to endure, but to avoid interference. Some philosophers argued that we should not assume malice from silence. Many researchers agreed. Perhaps the fragments had been programmed millions of years ago. Perhaps they wandered star to star, gathering data the way seeds drift across forests, carrying genetic maps of worlds they pass. Perhaps the hollow parent vessel was not a ship but a vault, a travelling archive moving between suns. But others were less comforted. Silence in their view was not neutrality, it was strategy. In Cambridge, a small group of radio astronomers and communication theorists gathered to analyse the structure of the prime transmission. They discovered something subtle, something troubling. The signal did not encode information meant to be interpreted. It encoded a self-referential structure, a test pattern, the kind of signal a machine might emit internally to verify its components were functioning, a diagnostic ritual, a systems check. If so, then humanity had not intercepted a message. It had overheard a calibration. This revelation reframed the fragments entirely. They were not addressing us. They were addressing themselves. And that led to a more profound implication. The fragments were now fully awake. What purpose they served, whether observation, cataloguing, surveying, or something beyond our conceptual frameworks, remained unknown. But they were not inert. They were not drifting contingencies. They were functioning artifacts. Humanity found itself for the first time in its history sharing its star system with non-human machines of unknown origin and unknown intent. In response, the tone of scientific discussion shifted. No longer were researchers merely cataloguing anomalies. They were confronting a new existential reality. Questions rose that no field had prepared for. What does a civilization become when its explorers are machines? How old must a species be to send seeds instead of emissaries? Are we witnessing the tools of a civilization long vanished, or one still active? Are the fragments observing us, or something deeper? Chemical signatures, planetary evolution, biospheric processes. What will they do when their survey is complete? Philosophers spoke of a humbling truth humanity had spent centuries imagining itself, the potential discoverer of life beyond Earth, yet now found itself the one being discovered quietly, dispassionately, without ceremony. The weight of that realization spread slowly across the scientific world, settling like a quiet mantle over every telescope, every sensor, every mind watching the fragments drift deeper into their chosen paths. For the first time in human history, the cosmos did not feel empty. It felt occupied. Long before the fragments completed even a fraction of their silent dispersal across the inner solar system, the world's scientific institutions began turning inward, redirecting their instruments, recalibrating their missions and reorganizing their priorities around an unprecedented mandate: observe, verify, and understand the presence now residing among the planets. It was as though the deployment of the fragments had triggered a global neurological response, an instinctive tightening of focus, a sharpening of sense, an awakening of scientific vigilance that spanned continents and disciplines. For decades, the tools of modern astronomy had been aimed outward toward distant galaxies, nebulae, the birthplaces of stars, the faint echoes of the early universe. Now, with sudden urgency, the eyes of science pivoted toward the solar system itself. Every telescope capable of tracking small, fast-moving objects was reassigned. Every radio array broadened its filters. Every planetary mission with line-of-sight advantage scrambled to adjust its protocols. Humanity had spent centuries scanning the cosmos for signs of life. Now it was the cosmos that had sent life's signature into our own celestial backyard, and every instrument was forced to confront it. The Galileo project, once a fringe ambitious initiative, found itself unexpectedly central. Its ground-based optical systems designed to detect anomalous aerial phenomena in Earth's atmosphere were suddenly repurposed to search for faint glints, reflective oscillations, or unusual trajectories associated with Fragment B. Teams that had once debated ambiguous lights now traced carefully plotted arcs, mapping the fragment's silent drift toward Earth's orbital corridor. High-speed cameras, AI-driven motion detection modules, and wide-field telescopes were integrated into a sweeping net of coverage. Meanwhile, on the other side of the world, the European Space Agency upgraded its optical interferometers to unprecedented sensitivity. Signal analysts were instructed to ignore conventional noise filters that might accidentally scrub away narrowband pulses, similar to the prime number transmission. New algorithms proliferated across observatories' software capable of capturing microsecond shifts in trajectory or faint modulated flashes that could indicate communication between the fragments. China, India, Japan and Russia initiated parallel efforts. Some were scientific, some were military. All of them understood that a transformation had occurred. Earth was no longer merely observing the universe. The universe was studying Earth. The most dramatic response came from NASA's deep space assets, the Deep Space Network. 3 massive communications complexes spread across the globe redirected portions of its time to scan the fragment's movement. Operators accustomed to listening for distant spacecraft now tuned into faint reflections from objects that gave no telemetry, no heat, no whisper of propulsion. The network's massive dishes, designed to track missions billions of miles away, were recalibrated to detect the quiet signatures of machines with no known technological lineage. Simultaneously, the James Webb Space Telescope, too distant and too sensitive to track the objects directly, was tasked with gathering environmental data from the regions through which the fragments passed. Subtle changes in dust density, scattered infrared reflections, or the faint possibility that a fragment might eclipse background starlight. Even Webb's instruments had limits, but no opportunity was dismissed. The solar observatories responded as well. The Solar Dynamics Observatory, the Parker Solar Probe, and the SOHO spacecraft began sharing data streams more aggressively than ever before. Analysts searched for patterns, slight distortions in the solar wind where the fragments passed peculiar particle interactions, changes in coronal brightness. Some speculated that the fragments might harvest energy directly from the sun's plasma. Others theorized they were measuring solar conditions, mapping its magnetic flux, or using its electromagnetic tides for internal calibration. Beyond these direct observations, new missions were drafted, some publicly, some quietly. Concepts for rapid response probes emerged in space agency workshops, small maneuverable interceptors capable of approaching one of the fragments and gathering high-resolution imagery. But these would take time, money, and political will, and the fragments showed no intention of slowing their dispersal. By the time such missions could launch, the network might have moved far beyond reach. On Earth, AI systems were trained to detect patterns in the fragment's movements. Some learned from orbital mechanics, others from swarm behavior seen in biological systems, still others from clustering patterns found in advanced communication networks. The aim was not to predict intent no algorithm could, but to understand the rhythm of deployment, the logic of motion. And beneath all this effort lay a deeper, quieter fear that science might not be studying the fragments fast enough. For centuries, instruments had been built to gather starlight from the distant reaches of space, to study supernovae, quasars, and galaxies older than humanity could comprehend. Yet these tools were ill-prepared for machines the size of compact vehicles drifting between planets at silent speeds. The solar system, once thought well-mapped, now revealed itself to be vulnerable, a stage too large for perfect monitoring, too dynamic for total awareness. Every telescope turned inward. Every receiver strained for signals. Every mission log grew thicker with the desire to catch the smallest anomaly. The presence of the fragments forced humanity to acknowledge a truth long ignored. Earth's instruments were designed for a universe presumed empty of visitors. Now they needed to detect the footsteps of something already here. For the first time in history, the scientific tools of humanity were not aimed outward to understand the distant universe. They were aimed inward, attempting to understand the new inhabitants of our own. When the fragments dispersed across the inner solar system, drifting like silent embers from an ancient fire, the world found itself standing before a threshold it had never prepared to cross. For centuries, humanity had looked outward through telescopes and equations, certain that the cosmos was a vast indifferent expanse, beautiful, yes, but empty of intention. Now, with 7 machines gliding through the starlit dark that certainty dissolved, the universe had revealed a presence not hostile, not welcoming, but profoundly enigmatic. And as the scientific community scrambled to interpret data, and the world's governments debated responses behind closed doors, a quieter, deeper set of questions began to rise toward the surface of human thought. What does it mean to be observed by something that does not speak? What does it mean when the sky, once a canvas of serene predictability, becomes a stage where intelligence beyond our own drifts silently between the planets? For many, the presence of the fragments triggered an existential trembling. If they were indeed Seed's mechanical scouts released by a hollow carrier vessel, then humanity was not encountering the civilization that made them, but the echoes of that civilization's intentions. Perhaps the creators still lived, or perhaps they had vanished millions of years before. Perhaps they sent these seeds across the galaxy like messages in bottles, trusting that the great river of cosmic time would deliver their instruments to new suns, new worlds. But the fragments did not seek communication. They did not declare arrival. They behaved like archivists, observers, instruments calibrated to a purpose humans could only dimly sense. Every new trajectory sharpened the unease, Fragment B slipping nearer to Earth's orbit, Fragment C aligning with Mars's thin atmospheric envelope, others drifting outward with patterns too deliberate for chance. And the parent vessel itself, the hollow body that had carried them across interstellar distances, settling gradually into a solar orbit that would give it a steady vantage point for decades. A watcher among the planets, a sentinel wrapped in silence. In universities and research institutes, conversations stretched late into the night. Physicists debated propulsion models not yet known. Biologists pondered why a distant intelligence would map a star system in such detail. Philosophers questioned whether the fragments were the first step in a process older than language itself, a cosmic method for cataloguing life matter and light wherever they were found. Yet amid all this contemplation, a quieter realization emerged, delicate and unsettling. Perhaps the fragments were not here for us at all. Perhaps Earth was not the focus, but merely one point on a long list of systems to be sampled. Perhaps our presence mattered no more than a chemical trace on a planetary spectrum. Or perhaps we were the most consequential discovery the fragments had made, and still they did not speak, because articulated dialogue may not be their purpose, or because communication for them is not an act of language but of observation, an accumulation of understanding measured not in words but in patterns and time. The fragments continued their silent routes. No acceleration toward Earth, no shift that resembled pursuit, only motion steady, certain, precise, as if following a script written long before humanity learned to shape fire from stone. And so the world found itself facing an unfamiliar mirror. The sky, once a symbol of vast distance, now reflected its own smallness, its own new vulnerability, its own new place within a universe that had quietly placed technology, older, wiser, and colder, beside us. What if this was not a visitation? What if this was simply normal? What if the galaxy has always been seeded with watchers like these observing recording drifting from star to star? And what if Earth for the first time is simply aware of that truth? From mountaintop observatories to deep desert radio arrays, from oceanic telescopes to spaceborne instruments, orbiting high above the atmosphere, humanity continued to track the fragments with awe, fear, and a growing sense of humility. Their silence no longer felt empty, it felt intentional, like the pause between breaths, like a presence measuring the world that had just awakened to its gaze. In that new quiet, the question that had haunted philosophers for centuries rose again, not with desperation or fear, but with the soft gravity of a truth finally confronting us. If we are not alone, then what precisely are we? Observers or observed children or peers? Anomalies or inevitabilities in a galaxy filled with ancient seeds? The fragments offered no answer. They only drifted on, unhurried, purposeful, and impossibly old. And in their silence, humanity felt the weight of a universe suddenly fuller, stranger, and far more alive than it had ever imagined. The solar system exhaled slowly as the new geometry of its skies settled into place. The fragments drifted on small, steady silhouettes moving against the vastness, yet their presence reshaped the imagination like tides reshaping a shoreline. The fear that had initially tightened the world's breath softened gradually into something quieter, a contemplation rather than a panic. For in the long sweep of cosmic time, every species must eventually confront the truth that it is not the only pattern written into the fabric of existence. No alarm sounded. No wars began. Instead, humanity turned its eyes upward with unfamiliar stillness, listening to the quiet where words would never arrive. The fragments did not glow brighter, did not drift nearer, did not break their formation. They simply continued, each gliding along its narrow thread of orbit like a lantern carried by an unseen hand. And in that gentle certainty the sky seemed less threatening and more wondrous alive, not with danger but with possibility. Nights grew slower. Dawnlight lingered a little longer on observatory domes. Students sat with open notebooks, unsure whether they were studying astronomy or philosophy now. The distinction no longer mattered. What mattered was the hush that followed the revelation, the understanding that the universe had never been empty, only waiting for its quiet truths to be noticed. The parent vessel, dim and constant, circled the sun with the patience of something that had crossed gulfs far larger than the space between planets. It did not hurry. It didn't hide. It simply was an ancient object sharing the stars' warmth with every world that had ever wondered if it was alone. And as the fragments continued to drift like slow-moving constellations, humanity, small, bright, hopeful, drifted forward as well, stepping gently into the vastness of a story far older than itself. The sky was no longer silent. It was simply speaking in a language we were only beginning to hear. Sweet dreams,